All right, good afternoon. Welcome to the fourth lecture of optimization in finance. Today we are going to talk about the four topics, starting with bonds. So just to give you an overall introduction to bonds before getting into the details of how the bond contracts are built. I'd like to think of a bond as a contract between a person who wants to lend money to another person, or an entity who wants to lend money to another entity. So this is essentially a very detailed and precise way of kind of aligning the terms for that contract, which is lending money from one person to the other person. So let's get into that and have a look at a specific example of how a bond structure, how such a contract can look like. So let's say that person A wants to lend 98 krona to person B, and the terms of that contract are set forth in the following way. The price of the bond, so I said that I want to lend you 98, let's say person A, I want to lend you 98 krona. So I say, well, the price of this contract is 98. Then, well, you can have as many of this contract. So this one contract costs 98 krona. And for that, I want you to pay me back this cash flow. So essentially, a bond is just telling you what is the cash flow between us in terms of having this transaction of lending and borrowing money. So I'll lend you 98 krona. And then what I get in this case, I get the coupon payments. I get 5 krona at the end of year 1, 5 krona at the end of year 2, 5 krona at the end of year 3, and then I'll get the face value or the par value, which is always defined to be 100. So I'll pay you 98. I get 3 times 5, plus I get my money back, but I get the money back at par at 100. So that's just essentially a convention. I get the 100 plus the coupon, which is 105, right? So this is just a contract. We could have agreed on a different kind of cash flow, but this is just how a certain kind of bond, in this case, what we call this is a bullet bond. So this is how a bullet bond is defined. A bullet bond is defined by having an initial price. Then the cash flow for that is comprised of the coupons plus the face value, which is always 100, plus the coupon at the final date of the bond, which is also called the maturity or horizon. So there are a bit of terminology around bonds that you have to get used to, and that kind of makes it quite clear what are the terms of lending and borrowing between these two parties, right? So this is the way a bullet bond defined. Now let's get a step actually back and look at the simplest structure that we can imagine for lending and borrowing. It's called a zero coupon bond. So as we saw with the bullet bonds, there was something called coupons, where I was giving you 98 krona, and then I was receiving back some coupons yearly of 5 krona, plus I get my face value plus the coupon at horizon, right? So that was the definition of bullet bond. But now if you take a step back and look at the simplest structure of lending and borrowing between two persons, that would be a structure like this, which is called a zero coupon bond. So what happens with a zero coupon bond is that we essentially just decide on a price. So in this case, I can lend you 78 krona, and then I say at maturity, let's say maturity is 4 years. After 4 years, I will receive the face value of the contract, which is 100. So I'll essentially give you 78 krona, and I'll receive 100 back in 4 years, right? So this is structure called as a zero coupon bond, the simplest bond structure that we can imagine. Right. Now let's look at how we price such a structure. If we want to start with the zero coupon bond structure, I'll give you the example over here. Once again, so we have a price of 78, let's say, and then at the end, this is maturity horizon at year 4. I receive the face value at par, which is 100, right? So now here comes the price formula for a bond, which looks like this. So you have the price of this particular bond is equal, and what you have over here is the sum of discounted cash flow. So F stands for the cash flow of the bond, and 1 plus RT, I'll get back to that, what that is, in a second. So let's start with the F. And in the case of this particular structure, what is the cash flow? I pay you 78, and I receive only one payment. So the cash flow in this case, the F, is only one payment, and that is a payment of 100. So I receive 100 back, and then here I have 1 plus R. And then it says RT and T for time. So what is T in this case? If you have 4 years? 4, right? And then I have to the power of T, which is in this case the power of 4, right? All right. And now, well, in this case, I gave you the price. So I have the price of 78, which is 100 divided by 1 plus R4 to the power of 4, right? Okay, so there's two ways essentially to go about this formula, right? In this case, I gave you the price. Well, you know, it's a zero coupon bond, so you get your money back, or I get my money back at par at horizon. That's my cash flow. And then I discount this with the 4-year interest rate. So this is the 4-year interest rate. I discount this money back 4 years, and that brings me to the price. So this is essentially what the pricing formula is about, is the sum of discounted cash flows. You've heard about discounting? Some of you have? So this is essentially what discounting is about. You are discounting a value, in this case 100, which you're going to receive in 4 years. You are discounting it back 4 years, and you do that with the 4-year interest rate, right? So this is the 4-year interest rate, which is connected, in this particular case, that is connected specifically to this particular bond, right? Now, can somebody tell me what is then, if I want to isolate R4? Is that easy, or is it difficult? That should be, it's laughably easy, right? So 1 plus R4 to the power of 4 is equal 100 divided by 78, right? Which is, then you have to get 1 plus R4, which is the 4th root of 100 divided by 78. And then, well, this thing minus 1. So can anybody give me what is R4 in this case? So what is R4 for that? Yeah, you have it already? 6.4%. 6.4%. So that means that R4 is 6.4%, right? Which kind of makes sense, right? So you can get a sense of it if I give you 78 krona, and then I'll get an interest rate of 6.4% on that. That would be the interest rates that I will be, that would bring me to 100 at the end of the 4th year, right? So it's like 4 times, I get 1, 2, 3, and 4 times that amount on about 80 krona, which more or less I can, in my head, imagine it's like, what is 6% of 78? Something like 5 krona, and 4 times that, 20 plus the interest on the interest. So 78 plus 20 approximately brings me to 98, plus the interest brings me to 100. So what I suppose that you calculated correctly, so the right number, that's 6.4%. right? So this is essentially, this is about discounting. I'm discounting 100 krona back with the 4-year interest rate, which in this case was 6.4%. Now actually comes an interesting question for you. Which one comes first in the bond markets? Is the price, does the price come first or does the interest rate? Which one do we observe in the financial markets? Do we observe prices or do we observe interest rates? Prices, right? There are two choices, right? So, it's true. So there is, like any other market, when you go to the bond markets, you observe prices. There is always, when you have to do with the markets, there is, there's somebody who's selling something and somebody is buying it, right? And for that, they agree on the price. So interest rate is essentially being derived from the prices of the bonds in a given bond market. In this particular case, what is it that is for sale? This particular cash flow of 100 in 4 years. So you go to a bond market and somebody says, well, how much are you willing to pay me if I pay you back 100 krona in 4 years? And somebody might say, well, I'll give you 70, and then somebody else might say, I'll pay you 75, and somebody goes 76, and finally it goes to the highest bidder. Somebody wants to pay 78 krona for receiving back 100. So essentially it's this bidding for receiving a cash flow in the future. A bond is a contract and a cash flow in the future. And for that, you will give a price like you would give a price for any other product, right? In this case, the product is just the cash flow that you're receiving back, right? So the prices are what are being observed in the bond markets, and from that, you would receive the interest rates. And this is what we are going to work with more during today, actually, and you are going to be working with a bit more complicated structures than this one, for which you actually need an optimization routine. Now let's get this a little bit more complicated. So let's see if I want to go back to the other structure that we started out with. This one, right? So this was a bullet bond structure. And let's see how that one looks like. So I just want to apply the same formula, the price formula. I have a price of, in that case, the price is also given. So the price is 98. And the price was the sum of discounted cash flows, right? The sum of ft divided by 1 plus rt to the power of t. And in this case, now I have more than one cash flow, right? So I have 5, 5, 5, and 105. So let's write that. So I have 5, and then here it would be 1 plus r1, right? To the power of 1 plus 5 divided by 1 plus r2 to the power of 2 plus 5 divided by 1 plus r3 to the power of 3 plus 105 divided by 1 plus r4 to the power of 4, right? So this is the sum of discounted cash flows. These are the cash flows, 5, 5, 505. And this is how we discount each and every one of them. This is the payment after 1 year. We discounted back 1 year with the 1-year rate. This is the payment at year 2, discounted 2 years with the 2nd-year rate, and so on and so forth, right? Now comes the question, is this one, is there, well, I mean, for one thing, is there one solution to this equation or more than one? There are several, right? So from this one, from this particular equation, you cannot tell me exactly what is R1, R2, R3, and R4, right? You can find many solutions which would fit, but none of them would be the true or a good approximation for the interest rates in that particular bond market. So essentially, in order for you to find out what are R1, R2, R3, and R4, you need more than one bond. So if you were in a market where you were dealing with bullet bonds, then you have to have, let's say, a 1-year bond, a 2-year bond, a 3-year bond, a 4-year bond, and so on, in order to decide what these values should be, right? So that's one of the cases. The other is that if you let's say if you don't have let's say if you have bonds up to 30 years, but you're lacking some numbers. Let's say you have a 20-year bond, and then you have a 25-year bond, and then you have a 30-year bond. So you have some missing horizons in the bond market you're observing. Would that then cause you any kinds of troubles in terms of deciding specifically? Because, I mean, if I gave you 3 bonds, a 1-year bond, a 2-year bond, a 3-year bond, then essentially you can first solve for the first-year bond, the 1-year bond, in a structure like this, find what is the interest rate, fix that, and then you go 1 year ahead, then you have the first year fixed, then you find out what is the second year's rate, and then you have R1 and R2, and then you fix those for the third bond, and they go for year 1, 2, and 3. Well, the problem comes if you have missing links, then what can you do in order to find out what the R's are? Any ideas? Well, we're going to get back to that after the break. I'm going to show you one way of going about it. It's a simple bootstrapping method. There are actually, you can take a whole course in working with interest rate theory and interest rate modeling. And much of it is actually about finding out some reasonable way of assigning some meaningful values to these R's. But we start with a simple one here after the break. Right. So far we've gone through what is a bond, and we have seen 2 examples of bonds, which is a zero coupon bond and a bullet bond. There's another type of bond that I want you to read about yourself, but I'm not going to go through here, which is called an annuity, which is a very important bond structure. An annuity is essentially the kind of bond structure that you would encounter if you were buying, let's say if you were borrowing money to buy a house. And the specific thing about an annuity is that rather than paying only the coupons and then paying the whole thing at the end, what you would do is that you pay a little bit of interest rates and then and a bit of the principal of the final money. So you pay equal amounts. So annuity is about paying your debt back in equal amounts yearly. And this is a nice construction if you were buying a house, because you can't afford that, to pay the whole thing at the end, but you want to pay the bond slowly, and you bring down also your debt as time goes, also minimizing your risk exposure to, let's say, if the house prices are going to crash after some years or what have you, then it's a good idea to bring down your debt as well. At the same time, you pay it in equal amounts. So I want you to read about annuities, and then you have structures where you have bonds with embedded options, and those are specifically, I mean, you have cases like mortgage-backed securities, which is a specific example of this, that they can have some embedded options in them. And those are kind of more complex structures. You would encounter some of them in the course financial products at this university. But we are not going to go through these more complicated bond structures, so I'll keep to the bullet bonds for the purposes of the rest of today and next week, and also for the midterm exercise that you are going to go through. Just one question is if anybody has seen already the video on the ascent of money and the section on bonds. For the 4-hour video, there's a 45-minute session on the bonds. We're just wondering if you remember, if anybody has seen it. So when did we get the first bonds? When, around which century were we introduced to the first bonds? Right? The city-states in the 1400s, right? So this bond structure actually, this is a structure which is about 600 years old. And there is it's actually quite an interesting observation that was done, is that as you were mentioning, that during the times of the Italian city-states, there were the city-states who actually came up with this structure. They managed to fund their wars against their neighbors much more efficiently than their rivals, because that was at the time more or less the only way that this governments had to to collect money for going into fight was, well, I mean, it's either directly by taxing the citizens of their cities or by essentially going and plundering the rivaling city-states, right? And this was all of a sudden a third way of funding your wars, because they could, rather than taxing your citizens, you can actually borrow money from your citizens. And in that way, they managed to issue those bonds to their own citizens, and they could collect a lot of money that way. And then, well, that actually meant that then they won their wars. Then they could kind of plunder the cities, the rival cities, and get the money back to the people who had invested into this money. So that was not just taxing one way, it was about getting the money and bringing it back. So essentially the structure was unfortunately built on wars, which is unfortunately the case with many other inventions as well. But since then we are seeing the usage of this structure in many other forms, which, for example, in the case of annuities, mortgage-backed securities, this is the regular way today for us to purchase a home or to do any other transactions which require a huge sum of money that you need to borrow some money from the bank. All right, so that's the first part of the lecture.